Okay, thank you. Okay, so it's quite important that we keep in step, like I said, and that's why we came up with this idea of artificial intelligence, how it contributes to research, and we have to really season the speakers. The first is in the person of Dr. Dibia. He's a member, he's still a member, but he was a president, I think that was in 2015 or about, of the association, and he has gone on to work with Microsoft, and he's doing really remarkable stuff there. So we look forward to the very many insightful tips he's going to give us. And after his presentation, we're also going to have Mr. Ridwan, who also is another seasoned scholar. He's going to give us some very hands-on demonstrations of how we can actually deploy artificial intelligence tools in what we are doing in our respective research. And I'd like to think that whatever it is that they tell us, we can actually go beyond our research. We could not be in research per se, we could be on that kind of jobs, but whatever skill they impart to us today might actually be transferred to any other thing they would like to do. But it's just important that we should listen, we should learn, and to make the most of the opportunity. So please, if you can invite other people, send the link to people. It's going to be public. It's more or less public, so everybody's expected, everybody's invited. So once again, we welcome. And as I hand it back to the host, Mr. Sopruchi, to continue with the event. Thank you everyone for joining once again. God bless you.
Thank you, the President, for the wonderful opening remark. At this point, I'm going to hand it over to Ms. Joyce for the minutes of the last bottling.
Okay, thank you so much, Mr. Coordinator. Sorry, am I audible? Okay, I should be.
Yes, you are.
Okay, so the last meeting, I'll be taking the minute of the last meeting, which was actually held during the handing over and welcoming ceremony in 2023, October. So I sent the copy of the minutes to our email. So please, I enjoin you to read along. You can follow along as I read. Thank you. Minute of the handing over and welcoming ceremony for 2023/2024 academic session. The ceremony was held in room Z503 of the Hong Kong Polytechnic University on Saturday, October 7, 2023. Although the program was scheduled to start at 2 p.m., started at 3 p.m. with about 10 members, and one of our guest speakers, Mr. Gabriel Ezekiel, who came before the scheduled time. The program commenced with the recitation of the second stanza of the national anthem, after which we had a welcome address from the president, Mr. Adegu Miracle. He appreciated the members and the executives for their support for the association during the 2022/2023 academic session and asked for renewed support for the activities of the association and the incoming executives. After this, we had the talk from our first guest speaker, Mr. Gabriel Ezekiel, an established Nigerian expert in Hong Kong. Before commencing his talk titled The Big Break, Utilizing the Financial Space of Hong Kong, admonished members to abolish the idea of time and build habits. Please, could you mute?
Thank you. Go ahead.
And build a habit of punctuality, especially since we are now in the diaspora. His talk majored on 5 financial nuggets, namely your value proposition, detox, financial literacy, networking, and who you are. After this, he answered some questions from our members. We then had a short trivia, especially for the new scholars, about their knowledge of Hong Kong, and gifts such as customized flash drives were given to the respondents. Dr. Ijoma Gwani, a seasoned scholar and senior lecturer at Hong Kong Metropolitan University, was our second speaker. She gave a talk on HK101, Introduction to Academic Life in Hong Kong. As someone who had gone through the PhD system of Hong Kong and currently lectures at an HK university, she was able to provide insightful points for the old and new scholars about navigating Hong Kong's academic system. She also provided tips on how to land academic jobs in Hong Kong, with networking being a vital point. Questions were asked by scholars and she provided answers. At this point, the patron of the association, Prof. Lawal Marafa, gave his speech, during which he admonished the members to be of good conduct and continue to shine as good ambassadors of Nigeria. He recounted memories of how the Hong Kong people cherish the Nigerian football team and how Nigerians are known to perform excellently in their research here in Hong Kong. He also answered questions from members on how one can stay true to being patriotic to Nigeria. Afterwards, the new scholars introduced themselves to the community. There were about 10 new scholars in attendance, with the majority, 8 of them, studying for a master's degree at Lignan U, 1 undergraduate from HKU, and another master's student at HKBU. For the last set of sharing, we had 5 members at diverse levels share their experiences so that every attendee could benefit. Ms. Semi at INE shared her experience as an undergraduate student at HKU. Mr. Victor Udo shared his experience as a master's graduate from HKBU. Ms. Chiamaka Mbwechidimma shared her experience as a PhD student at CHK. Dr. Kelvin Orisharemi shared his experience as a postdoctoral scholar at PolyU, and Dr. Kainde Oyetunde shared his experience as a PhD graduate working in the HK industry sector. For the handing over ceremony, the school representatives, bootcamp facilitators, research and electoral committee members for the 2022/23 academic session were appreciated. Thereafter, the current executives, Mr. Adego Miracle, who is the past president now, Dr. Olutomilayo Peteri, who is the past secretary, Mr. Maradesa Adeleke, who is the past treasurer, Mr. Isanga Stanley, the past PRO, and Dr. Oladosu Ayomide, who is the past welfare officer, were given certificates of appreciation presented by the patron, Prof. Marapa. Subsequently, their offices were handed over to the new executives, Mr. Ogedengbe Ikeoluwa, the president, Ms. Akaniro Rejoice, the secretary, Mr. Abgafatunde, the treasurer, Ms. Mbechidimma Ochiamaka, the PRO, and Mr. Abo Soporuchi, the welfare officer. During the AOB session, while informing the members of the NHK branded souvenirs available for sale, the guest speaker, Mr. Gabriel Ezekiel, volunteered to pay for 10 souvenirs for the new students. This was highly appreciated, and he was also gifted one of the NSHK branded polo shirts. The secretary, Ms. Akaniro Ifuna Rejoice, informed the members about the mission and vision of ANSHK for the benefit of the new members. The president, Mr. Ogedengbe Ikeoluwa, gave the vote of thanks and encouraged the members to continually show their support by showing up for activities, paying their dues, giving communal support to their neighbor, and portraying Nigeria in a positive light. The meeting ended with Nigerian meals served to the delight of the members of the association. And this report was taken by Dr. Olutomilayo Peteri, the ANSHK secretary for 2022/2023 academic session. Thank you so much. So now I'll be moving the motion for the adjournment of the minutes. So having read the minutes you're hearing, if there are no questions or queries, I invite one of the members present to move the motion for adjournment of the minutes. Thank you. And please, if you have questions or queries, please let us know. Thank you.
The earlier we do that, the better for all of us.
And if there are none, please, I invite a member here who was at the event in October 2023 to please move the motion. Oh, please, let's try to do that as soon as possible. Or do I call somebody? Who was there? Dr. Kenny Oyetunde, please, could you help us move the motion?
Okay, I move the motion.
Sorry, is
Thank
that
you,
Dr.
sir.
Kenny? Okay. Okay,
Yeah,
thank you,
I
sir.
move the motion.
Okay,
Yeah,
okay, please let somebody second the motion.
Okay, Ridwan Salahudeen, I second the motion for the minute to be adopted.
Okay, sir. Thank you so much, sir. Okay, with that, we come to the updates, and okay, before then, we also have to take the introduction. So please, I would like us to unmute ourselves and introduce ourselves to the house. I'll be starting with the president, Dr. Ikeoluwa, please.
Hello, everyone. My name is Ugedingbe Ikeoluwa. I am the president of the association for the 2023-2024 session. Thank you.
Okay. Mr. Soporuchi, please go ahead.
I'll try the second person.
It doesn't matter, please.
So I'm Sapruchi Abo, welfare officer, PhD student, Poly.
Okay. Mr. Gafar.
Hello everyone. Good afternoon. I'm Gafar Tunde Tiami. CHK.
Okay, thank you. Mr. Adeniro Ibrahim. Hello, sir.
Hello. Yeah. Good afternoon. I'm Adino Ibrahim Ademola, Hong Kong Polytechnic University. Yeah.
Dr. Timothy Akinwande. Dr. Timothy.
Hello, everyone. I'm here. Yeah, I can hear you. Good afternoon. My name is Dr. Timo, HKMU. Thank you.
Okay. Dr. Lutomilayo.
Hello, everyone. My name is Olutomilayo Kwetinrin.
Dr. Kehinde Uyetunde.
Good afternoon, everyone. My name is Kehinde Uyetunde.
Dr. Mistura Salahudeen.
Good afternoon, everyone. My name is Mr. Salahudeen from Hong Kong Baptist University.
Dr. Toby Alabi. Dr. Toby, are you there? Okay. Mr. Shaibu David.
Hello, everyone. I'm Honora David. Nice to hear your voices.
Mr. Ridwan Salahudeen.
Hello, good afternoon, everyone. I'm Ridwan Salahudeen from St. Francis University, Hong Kong.
Mrs. Joya Deoti.
Good morning, everyone. My name is Joya Deoti. Thank you.
Mr. Kindness Onye. Mr. Kindness.
Hello, everyone.
Sorry.
Hello. Yeah, go ahead.
Okay. Hello, everyone. Nice to join you today. Yeah.
Sorry for introducing your title wrongly. Yeah. So, Mr. Godfrey Chibu, please rename your the name you joined with your real name so that I'll take note and acknowledge you. Thank you.
Hello, everyone. Nice to meet you guys. I'm Godfrey Chibu from Poly. Thank you.
Okay, we also have Mr. Kazim Kayode.
He won't be able to speak. He's occupied. He already sent a message.
Oh, okay. Dr. Temitope Kende.
Good day, everyone. My name is Kendi Temitope. I'm Poly.
Okay. Dr. Oladakbo Chris. Hello, Dr. Chris. Okay, we have Mr. Kayode. Please, can you write your name in full? Mr. Kayode, that's the name I can see here.
Is that me?
Yes. Yeah, just Kayode is the name.
Okay. Yeah. I'm Oyeshina Kayode, City University of Hong Kong.
Okay, thank you. Mr. Stanley Sanga.
Hello, everyone. I'm Stanley Sanga from CTU.
Mr. Daniel Wiyang.
He already introduced himself in the chat. He won't be able to speak.
Okay, in the chat. Okay, thank you so much. We have Hope. Sorry, please, if you could write your name in full, then I will be able to know. But please unmute yourself. Hope. The username Hope. Okay, we have another username with Goody. We have another username with Ridwan at Compatnia.
Oh, good afternoon, everyone. My name is Ridwan. I'm the data scientist at Science Park.
Okay, thank you so much. Okay, please, I'm sorry if I omit you, it's not intentional. I'm just trying to scroll through. But if I've not called your name, please kindly unmute and introduce yourself before we proceed. Thank you so much. Me, I'm Ms. Joyce Akaniro from HKBU. And thank you. Yeah. Okay, so I believe that's the end of the introduction session. So I'd like to also introduce once again the ESCOs for the current section 2023/24. We have the president in person of Ogedengbi Ifeoluwa, the secretary in person of Akaniro Ifunaya, the welfare officer, Mr. Aboso Poruchi, the information officer, Igbechidema Linda. She's not able to join because of other commitment. Then we have the treasurer, Tiamiyu Abgafar. Then here are the school reps for session. HKST school rep, we have Mr. Yoluwa Davis. HKU school rep, we have Ajibola Ogunsola. For Lignan, we have Mrs. Ruth Oyemi. For CHK, we have Mr. Daniel Dio. For Poly, we have Mr. Godswill Chibo. And for CTU, we have Mr. Stanley Isanga. And here is the calendar for 2023. We put up a lot of events for the session. And as you can see, we already completed some. Since November, we've been having a series of events. So we already completed some. And currently, we are having the academic forum, which is here. And we have other upcoming events in the subsequent month. And you are all encouraged to be in attendance as well. So in November, we had our first event. Let me see if I can just point up this. Okay, so in November, we had our very first event after our inauguration. And this is actually the first of its kind in the association. And this was because we discovered that most of the new students, we are master students, not just most, but all, we are master students. And to ensure that the association continues, it relies heavily on the PhD students. You know, master students are just around for a month, for a year, and they're gone. So we needed to make more awareness to create more awareness on the opportunities we have here so that we can attract more PhDs who actually will be here for a longer time and can ensure that the association continues. The event was a success. We had about 40 people in attendance, if I'm correct? Yeah, 40 people in attendance. After that, in December, we had our social event, which is the barbecue party at HKST. We had a lot of fun. We had a lot of scholars who came together to enjoy the break. So that was during the Christmas break. After that, in January, we organized the beach cleanup. And the idea behind this was that, you know, there's been a lot of reports about plastic pollution in the water, in the ocean. And this was to encourage to support the efforts of the Environmental Protection Department of Hong Kong in keeping these oceans clean. And that is also to protect our own health, because indirectly we have been affected by the pollution in the ocean. So we had about 13 people who volunteered for this event. And as you can see from the picture, it was a huge success. And for the volunteers, we gave them certificates of participation. So in February, we also had this other meeting event, and this was Teaching in Hong Kong webinar. And the purpose was to support our members who like to get teaching jobs during their study to support themselves financially or after studies. For this event, we had about 35 people in attendance, and we had three speakers from different schools in Hong Kong, and it was quite enlightening, and it was a huge success as well. Then in March, we had the football match with the Ghanaian scholars. This was on their Independence Day, and we were invited to this event. So our scholars, the Studios Eagles, are football players for the association. They did marvelously well at this event. As you can see, we had a lot of people in attendance, and we were happy to spend quality time with our Ghanaian scholars. Then in February and March, the ESCOs had courtesy visits to the patron, Prof. Lawal Marafa, and the Consular General, Dr. Adeyemi. And this was necessary because we wanted to ensure that we maintain the cordial relationship we have with them. We don't want it to be that we only contact them when we need them. No, we had to pay this courtesy visit so that they will know we actually acknowledge and appreciate everything they've been doing for the association. So in December and January, we had the meet and greet with the new scholars at the different schools. As you can see from the picture, HKBU, we had HKUST, we had HKU, we had Lingnan U. This were actually the schools we had new scholars, so we are there to meet with them. Then in the course of the year, we had a lot of good news, graduations, relocations, jobs, weddings, and newborns. And we say a very big congratulations to everyone on this list. And we are so sorry if maybe by omission your name is not here. It's not like we don't acknowledge you. It's just omission, and we are really sorry for that. So for the graduations, we had Dr. Kayode Oyeshino, who got his PhD, Dr. Temitokbe Idris, also his PhD, Timothy Akinwade also got his PhD, Dr. Timothy Akinwade, he's got his PhD, and Dr. Temitokbe Kende, he's got his PhD. So for the relocations, we had quite a number of them. Dr. Eson Oladapo moved to the USA, Dr. Sunday Lunayo moved to Canada, Dr. Bamidele Ola moved to Canada, Dr. Damilare Akingbade moved to Canada, Dr. Mayowa Adegoriola moved to New Zealand, Dr. Mujib Adeagbo moved to UK, and Dr. Kende Oyetinde moved to Canada. We also had our scholars who got jobs in different institutions. We have Dr. Mujib Adeagbo, had Dr. Mayowa Adegoriola, Dr. Timothy Akingbade. Then for weddings, we had our scholars who got married. We have Mr. Ikeoluwa Ogedengbe, Dr. Olutomilayo Okpetirin, Dr. Ayomide Oladosu, Mr. Godfrey Chibu. We also have our members who welcomed new babies. Actually, not just the members, but for all of us, because they are also part of the family. So we have Dr. Bamidele Ola, we have Dr. Ibrahim Adeniro, we have Dr. Kayode Oyeshino, we have Dr. Lekon Ojo, Dr. Temitokbe Kehinde, and Mr. Abgafat Yamiyu. Congratulations once again, and wish you all the best. Then for the financial report, I'll be inviting the treasurer to take over for that very report. Thank you so much, and enjoy the rest of the event today.
Yeah, good afternoon, everyone. I hope you can hear me clearly. Can you hear
Yes,
me?
sir. Hear you, yes.
Okay, good afternoon. It's been a while. Yeah. Once again, my name is Gafar Tunde Tiamiyu, the current treasurer of this association, and I'll be giving the financial reports of what we have plans and how far we've been going financially. First of all, I would like to state clearly that the report here is from October, when we assume of this till this day. So far, we've received some credits. First of all, we made some amounts of money in the bank, and that's 16,042 Hong Kong dollar. Then from October to today, we've been able to receive so many annual dues from our members. We received from 11 PhD and some graduate alumni from as their annual due, as well as some 6 master students. So in total, we were able to receive 7,312 Hong Kong dollar, then 42 cents. Then as well, we've been able to receive an annual due for last year from one PhD student. That's like 500 Hong Kong dollar. In total, we were able to receive 23,855 Hong Kong dollar 28 cents. Next page, sir. So in expenses, most of our expenses are on many of our events. Among them is the meet and greet, which we meet our new scholars in Lingdan University, on HKUST, in HKBU and HKU, as well as BBQ, which was held at HKUST. Then the expenses incurred during the football with the Ghanaians. Then there is this fixing of bank signatory, where the past executive has to we have to sign some documents, which require us to pay 200 Hong Kong dollar. In total, in the expenses, in total, we are able to spend 2,628 Hong Kong dollar for the 2 cents. Next. So in summary, from what we have in the bank, when we are sum of it and the amount of money we receive as annual dues, we have 23,855 Hong Kong dollar 28 cents. Then from our expenses, we have 2,628 Hong Kong dollar for the 2 cents. Therefore, currently in the accounts, we have 21,226 Hong Kong dollar and 6 cents. So I would like to mention that most of our activities, every expenses we incur are financed by all your annual dues. So that's why I would like to encourage every member that have not paid their annual dues to try and do so. And also as well, I would like to appreciate every member that have paid their annual dues. We always welcome you and always encourage you to attend our events. Most of our events are very educative and are very interesting. Even most of them are very are for fun. So we don't just take things very serious every time. So sometimes we go for outings, do so many other fun things. So we'd like to invite you to partake in our events so that you utilize every part of this. Thank you very much.
Okay, thank you so much. Please, Mr. Moderator, can you take over?
Yeah, thank you so much. From the number of our members that graduated, got jobs, relocated, welcome their babies, you will agree with me that the future is bright. And hopefully by this time next year, we'll have a longer list. So that concludes the first part of this meeting. We're going to move straight into the talk and webinar. So our first speaker today is Dr. Dibia, who did his PhD a few years ago at CTU. So Dr. Dibia is a principal research software engineer at the Human AI Experience team, Microsoft Research AI Frontiers. Some of his recent contributions at MSR include the development of new metrics used in evaluating candidate GitHub Copilot models in production, research on LLMs for automated data visualization, and tools for building multi-agent applications. Prior to joining MSR, Dr. Victor was a principal research engineer at Cloudera, applied machine learning product, and was a research staff member at IBM Research, New York, HCI, and applied ML research. Dr. Dibia's work has been published at conferences such as ACL, EMNLP, AAAI, and CHI, earning multiple Best Paper awards. He holds a PhD in Information Systems from City University of Hong Kong and a Master's in Information Networking from Carnegie Mellon University. I would like to invite all of us to welcome Dr. Dibia as he presents his talk. Over to you, Dr. Dibia.
Hi, everyone. Can you guys hear me?
Yes, we can.
You can also share your screen while I stop share. Thank you.
Yeah. Can you see my video though?
Yes, we can see
Okay,
you.
great. Wonderful. Wonderful. How's everyone doing?
Very well, very
Hi
well.
to me.
Hello,
I can
sir.
see you on the ground. All right. Let me share my screen. Verify that I can do that. Can you guys see my screen?
Yes, we can.
Yes.
Well, first of all, thank you so much for having me. Thank you for inviting me. I know that like the timing was different, but you guys had to shift it earlier because of me. I really appreciate the effort that was put into that. It's great to see fellow Nigerian students from Hong Kong. So today I'll be talking about some work I've been doing around applying generative AI models to solve problems. But essentially, with our group, we are looking at a potential future scenario where we have like a bunch of agents, each of them powered by generative AI models, and they sort of collaborate to solve problems. I know I have about 20 minutes, so I might be a little bit fast, and that will be deliberate. I'm happy to provide additional follow-up resources for anyone who's interested, or even have like a follow-up call or something like that. In terms of background, my name is Victor Dibia. My background is in software engineering, distributed systems. And then I did a PhD at City University of Hong Kong, I think from 2012 to 2016, thereabouts. Yeah, if I recall correctly. So about 4 years, I lived in there about 4 years. And fun fact, the ANSHK logo, the green thing with all of that, I designed that logo many years ago, and I was like secretary and then vice president and all of that. So all of this brings back memories. So after during the PhD, essentially I give a brief background about how I got to Microsoft from Hong Kong, in case that's interesting, because one of the challenges, back then studying, it's always like, hey, I studied in Hong Kong, I have a degree in Hong Kong. How do I make that move to the US? Because the US is just a good place for a software engineering, computer science research career. Something that was very helpful was that sometime in my second year, I started looking for internship positions, and I did get one in my third year, and that happened to be IBM Research. So in my third year, I did an internship with IBM Research for about 4 months in New York. And then after that, I got a return offer as a postdoc, and essentially that's how my career started. Spent about 3 years at IBM Research with a primarily HCI group, human-computer interaction, also working with a close AI group. And then after that, I spent some time at a company called Cloudera, applied machine learning engineering research, and then I moved to Microsoft Research. And so on Microsoft Research, I work with a team called the Human AI Experiences Group, and essentially we care about scenarios where a human works in tandem with an AI model to solve a problem. How many of us here are familiar with GitHub Copilot? A few people, okay? So essentially GitHub Copilot was released, I think, about two years ago. And essentially it's like the first example of a generative AI model like we know today, things like ChatGPT, models as big as ChatGPT, integrated into a product at scale. So GitHub Copilot is a plugin in an interactive development environment, an IDE called VS Code. And the core value here is that as a software engineer, as you type code, imagine you're trying to write some code. It could be anything. It could be code to plot charts, analyze data, just whatever. And right as you're writing your code, essentially the LLM is inspecting all of the files that you have open, your current file, and it's suggesting code that might solve the current problem that you're working on. And a lot of this has gotten a lot of use. Hundreds of thousands, probably millions of people have used this. And essentially, I worked on the team that helped evaluate and ship that product. So that's kind of one of the things I worked on at Microsoft. Today, though, I'd like to go over like the idea of building multiple agents. And so I'll give an overview of what this might look like, why we might want to use agents or groups of agents working together. And then I'll talk briefly about Origin, which is a framework, an open source project that we have created to make it just slightly easier for people to build this sort of applications. It's also like a test bed for us to sort of learn, continue to grow, conduct research, and sort of understand the space of multiple agents working together to solve a problem. So to give a background, a lot of us that are in the computer science field, at some point we have all thought about the idea, have all toyed with the idea of a machine or some software or some entity that can help us with very, very complex tasks. And so that way we leave all the complicated, repetitive, boring stuff for the computer to do, and we spend our time doing things that we as humans enjoy and find fulfillment from. Let's say we wanted to write a novel, we might give it some high-level plot of the novel, and then we would ask this model of the system to expand it into, let's say, 200 pages of material. Give it some feedback along the way, that kind of thing. Or we might ask it to work in a supply chain problem. So let's say I want to open a new coffee shop in Ikeja, and there's a coffee supplier in Oshodi. The question is like, if I wanted to run my coffee shop in Ikeja at profit, can I exclusively use the supplier from Oshodi? And to answer that, we need to do a bunch of research, figure out the current state of affairs, figure out, what was the cost basis, transportation, logistics, all of that, would all this work. And imagine that we could give this to an agent and it will do all that's needed, send the right emails, get all the information needed, and come back, give us a reply or some recommendation with evidence. The third thing, if we bring this home to the computer science domain, a lot of us build software. This software has multiple components. So imagine that we could give some agent like this task, build me an app or a whole website or a whole web application that does X. And it goes back, it does all the work. It might come back, ask us for supervision, tips, that kind of thing. But it does most of the work. And in this future, the agent becomes like the primary interface to the digital world, right? So right now, we all use like a computer, a screen, mouse and keyboard and all that. But maybe in this new future, we instead just give instructions in natural language and the agent does most of the work. And so across all of these tasks, they're in different domains, but a few things are common across all of them. And the core idea is they're all complex in some way. And to give some example of some properties of what this complex task look like is, first of all, it requires planning. We need to decompose the task into multiple steps. If it's a task that has just a single step, it's not a complex task, and you probably do not need agents for this. The second thing is that the task usually might benefit from multiple experts collaborating together. And so just like organizations function today, you have an accountant, you have software engineers, you have HR folks, and complex tasks usually require multiple experts that can sort of focus on specific areas. Another property of complex tasks is that in essence, you might need to process a lot of information to make sense of the problem, or as part of processing the problem, you generate a lot of information. Now, generative AI models today have some limitations in how much information they can process at a given time. And so it just makes sense to decompose the problem and sort of solve it iteratively, perhaps using individual agents. And then finally, some problems just exist in a dynamic environment. And so what that means is that failures might occur. You might need revisions to whatever plan of action you have. You might need to constantly review your current status. And essentially, to solve this sort of problems in the dynamic space, you need some type of metacognition. The metacognition is like the ability to make plans, monitor your plans, review them, make changes as necessary until you solve a problem. And it's a critical capability for intelligent human beings. And it also turns out that like to succeed on complex tasks, you need some type of metacognition. So what are some examples of this sort of tasks? I talked about the supply chain problem. We have like, we want to open a new cafe in Ikeja. Can we use, let's say, a coffee supplier from Oshodi? To answer that, you need to gather a bunch of documents. What is the status? What are other coffee shops doing? Are there any subject matter experts that we need to reach out to? Are there any databases that we could query to get additional information? How can we compute the right financial analysis? And then how do we come up with a final report? Similarly, with the software engineering problem, let's say we wanted to build an app. We might break this down into structured steps. Number one, we want to gather requirements. What are the key functionalities that this app must support? And for that, we might ask questions to a human. In addition to that, we might want to lay out the user experience. What are the different screens? What should be on the screens? Once we have all of that, we might give that to an Android engineer who will implement each of the screens. And as part of that process, the engineer might have to write some code, compile it, any errors that arise, sort of address them. Then we created some backend service that this front end like sort of consumes. We do some integration testing, and then we get a final application. And so the key point here is that for each of these two problems, we need some sort of ability to reason. So here it might be just planning, it might be deduction. We need some ability to act. Let's say we need like some way to write some code and execute it. We might need to make calls to like read documentation and all of that. We need some way to adapt to any failures that occur along the way. So let's say we write an initial version of the app. It has a bunch of errors. It turns out that the SDK, the Android SDK has been updated and the current code we have doesn't work. And we need some way to sort of react to that in some automated fashion. And then finally, we want to communicate, so send messages across agents and across humans. So that's like the core definition of an agent, an entity that can reason, act, communicate to solve problems. So why might we need like groups of these things working together? And so a lot of us on this call, we've heard of like generative AI, LLMs, ChatGPT, and we've also heard of things like hallucination, right? And so you could ask the LLM something like, what is the height of, I don't know, the tallest building in Hong Kong? And it will tell you that because it probably has seen information like that in its training data. But if you asked it something, let's say a bit more recent, like what happened in, I don't know, 21 yesterday or something like this. So you asked it like, what is the stock price of NVIDIA in the last week? Now, this is the information that an LLM is unlikely to correctly answer because perhaps it was trained like 6 months ago and that information just did not exist. And so typically when we design systems to address that, we'll give the LLM access or the agent access to tools like, let's say, being able to search the internet. We might give it access, the ability to write and execute code. So for example, to understand the stock price of NVIDIA, it needs to write some code, download some data, process that data, generate some charts, and then render that chart. And so that's like the next step of evolution, giving the LLM access to tools. However, when tasks become more complex, like build a mobile application that can view stock prices, all of that, and file taxes, then you actually need like separate expertise. This task can go on for, let's say, even minutes, hours, and you actually need multiple agents sort of collaborating together. Similarly, if we build applications, we can think of it in three different phases. Number one, what we see today with ChatGPT, you ask a question, ChatGPT gives a response. In some cases, it might tell you, okay, here's some code, go and execute that code. You execute it, you come back, you tell it, oh, there was some error, that kind of thing. It suggests some response, you get the result. In this regime, there's a lot of effort from the user, medium adaptation. In the next version of this, some of us might have heard of tools like LangChain that lets you express a problem, the solution to the problem, as a bunch of steps. So let's say if we consider the problem of plot the stock price, we might build a LangChain pipeline that says, okay, we take in the user's request, we extract the right stock symbol, we make a call to the Yahoo Finance API using the stock symbol. Then we have yet another step in the pipeline that uses an LLM to generate some code. And then we have a code executor, we execute that code and get the response. Here, it requires that the developer knows the solution and has the right expertise to sort of build this pipeline. However, the one drawback here is that this pipeline perhaps can't answer any other type of question. However, if we take the multi-agent approach, rather than trying to build the actual solution, instead we define a bunch of agents and we let the agents sort of engage in a conversation to solve the problem. So that's kind of like one additional benefit of a multi-agent approach. The first is that, as tasks become just more complex, just a single LLM or a single agent might not work. Also, when the task has high adaptation requirements, let's say when, for example, maybe you don't have enough developers to actually implement the tool, or the task, resides in a dynamic space that requires like agents that can adapt autonomously to address the task, then maybe a multi-agent approach makes sense. So why is all of this important now? The biggest factor here is that we now have LLMs that can reason. And so previously, domains like robotics, swarm intelligence, they've extensively considered the idea of like autonomous planning, multiple agents collaborating. But I think one of the things that has held back that line of work is that we just didn't have like actual high quality synthetic reasoning engines. And models like GPT-4 from OpenAI, say Gemini Ultra, they sort of bring that capability, and suddenly we can build this sort of complex applications that can sort of reason, act, adapt, solve problems. Then there are other like things around like, because now we can do all these new things. Maybe we have ways to enable new types of automation. We can innovate in that space. And then all of this brings up its own ethical challenges that we must also solve. And so given all of these benefits, and if we agree that multi-agent is the future, or at least a potential next step in how we build tools, one challenge that's sort of out there right now is that to build multiple agents that do all these things, you actually have to write a lot of code and essentially build a ton of expertise. You need to figure out, how do we define an agent? How do we give it access to an LLM in a way that it can use that efficiently? How do we define the properties of these agents? Let's say how many turns or steps they can take. How do we define like stopping conditions or task termination conditions? How do we give the access to tools like code interpreters, APIs? How do we enable agent interaction and orchestration? That's like, what other agent can one agent talk to, and how do we define like which agent speaks or requests or receives the information at any given time? To address that, our group has built this open source project called AutoGen. It's essentially, the goal is to empower developers anywhere to not just use agents, but create their own version of these agents. And so AutoGen, there are three important tenets or design principles. The first is conversation-based programming. What that just means here is that to solve a task, the goal is that we want to create an agent, a group of agents to solve a task. And how do the agents do that? They do that via conversation. So essentially, you can think of, there's a task, it's the current state of the problem. An agent can start a conversation that says, okay, here's a plan. It's added as one step in the conversation. And another agent can react to that. Okay, here's an action we can take. And essentially, as they sort of react to the messages that get sent, all of this can be structured as a conversation until the task gets solved. AutoGen also provides an easy, flexible API that's easy to use and can be composed to solve with simple and complex problems. And then finally, because it's open source, we can integrate it into a lot of different other things. So I will move a little faster now and just show an example of what it means to define an agent and get them to solve a problem. And so AutoGen uses a define and converse like paradigm. So first we define the agent, and in this case, we're defining two agents. The first is something called a user proxy. The only special thing here is that we give this agent the ability to execute code that it receives. The second agent is just think of it as like a ChatGPT or any agent just has access to like an LLM model underneath. And then to solve a problem like plot a chart of like Meta and Tesla stock price, we would say something like A.initiate chat to B. And what happens there is it's agent A gives out the task. Agent B says, here's some code that can be written to address the task. Agent A executes that code, extracts the code from the message it receives, executes it. There's an error that has occurred. Then agent B says, okay, hey, here's some code to recover from that. Some more installation gets done until the chat is received. Maybe some feedback might be provided until you get to the solution of the problem. And so now the agents might not identify the most efficient path to the solution, but still, at least in the current implementation, we have an actual, some type of path to the solution, all structured as a conversation. And so these agents can be composed in simple workflows or even more complex workflows. So there's a paper associated with AutoGen, and if you do have a chance to look through it, you'll see some of these examples like agents solving math problems, agents working as a team to write code, dynamic group chat, agents playing chess, that sort of thing. I'll switch to a quick demo. I don't know how much of my screen you guys can see, but there's a part of this project that I've been leading, which is something called AutoGen Studio. And essentially, it's a no-code interface that just lets users or developers prototype this sort of multi-agent applications. So the core idea is that we want to be able to build agents, so we can select create an agent, set up some of its initial instructions via system message, we click create. Next, we can attach a model, an LLM model. So there's a different tab where we can create models. So we can use OpenAI GPT models, we can use open source models, we can use Google models even. Then we can explicitly give these agents access to tools. So for example, we might tell this agent, hey, you have the ability to generate image. And the skill here is just the Python function that says, if you need to generate an image, here's how you can call the OpenAI API and give it some sort of instructions. So once we've defined the agent, we can then compose it into workflows. So for example, say ANSHK workflow. We create that workflow and we can add an agent. We can add an agent and then add some other agents. Essentially, the initiator is just the one that initiates the conversation, and the receiver is the one that receives that. So once we've created our workflow, we can create a new session. And let's say we use this default one, and we might give them an instruction, tell them to paint a picture of Vegas in summer. I know it's a bit of an ironic question because we didn't have summers in Nigeria, but let's just see what happens. So essentially, the agents start to converse, like send messages across themselves. So the first one says, here's what the user said. The second one says, hey, we have access to a skill called generate and save images. How about we use that skill, write some code, and we use that to try to call that API and then generate images. And then what happens is that piece of code that was written just gets executed, and then some sort of some image gets generated, and this is what it looks like. So this is just an example. In theory, you could compose these agents to do even more complex things. Tell them things like generate me a whole video, generate me, like, I don't know, conduct some research, read a bunch of papers, synthesize that, give me some results, that kind of thing. So that's just like a quick demo. I will skip. I know I have just a few minutes left, but I'll skip to open challenges and then I'll end here. I know I painted a rosy picture of what this multi-agent space could look like, but there are a lot of open problems here. When you get agents to sort of chat or converse to solve the problem, they might not choose the most efficient approach to solving the task. And they might, they might collaborate and go maybe fall into local minima and not converge at all. So you lose a bit of reliability there. While you get some adaptation, there's a bit of a trade-off there. It becomes hard to really evaluate the systems because LLMs are stochastic. And then if you combine all the interactions across multiple agents, that makes it even hard to sort of predict ahead of time what the result might look like. And there are safety privacy issues. There's learning and memory issues, personality focus, task termination, all that. So the final takeaway is not all tasks require multiple agents, but some do. So tasks that require planning, diverse expertise, extensive context, adaptation to dynamic environments. So things like, can you take all my invoices, extract all the data from that, put it into my Salesforce or my HR system. An agent can work well for a task like that. If the task is, what is the height of the Eiffel Tower? Now, this is simple. You don't need multiple agents. So multi-agents might not replace any jobs anytime soon, but the scope and the complexity of tasks that we can accomplish autonomously is going to change, expand. And then there are many open research interesting problems here. And this is like a call for participation. AutoGen is actually open source. It's a great way to get into this space if you feel like you have some cycles. We have about 250 active contributors, and I'm always open to sort of helping more people join. So I'll stop here. If there are questions, let's have a quick discussion. That's okay. Oh, by the way, can folks still hear me?
Yes, we can. Thank you.
Okay.
Tunde, you can take it up from here.
Okay. Thank you very much for the nice talk. Very, very interesting. In fact, I really enjoyed this particular discussion. It's very, very interesting. Thank you so much. It's well delivered too. So, to our audience, if there's any question, please, let's hear them. I think we have one question here. Should I read or you can read from the chat box?
Let me see. So it's from Mistura, right?
Okay, yeah. He said, thank you, Mr. Dibia. Can you see that?
Yes, I see it, yeah.
Okay.
Yeah. So the question is two parts, right? The first is what do I think about the fact that some jobs might go away? And the second part is what is the impact in human creativity? Yeah. Should we envision a future where tech gets smarter and humans get lazier? So I mean, I appreciate the irony of all of this because if we succeed at this, then it means that even some of us working on this stuff might be out of a job. I can appreciate the irony of all of that. But I think one way I'm thinking about it is that AI and generative AI and agents are part of a long technology revolution, right? So first there was the Industrial Revolution. We figured out ways to build things at scale in industries. We figured out ways to automate the manufacture of cars. Then there was the Internet Revolution, where we figured out how to communicate across long distances. This is mobile revolution, things like GPS. And AI is just another step in that whole thing. Now, I know that AI is different in many, many ways, but the point, the important thing is that I think at every point when these revolutions occurred, humans have figured ways to sort of, the nature of work just changes just a little bit. So everybody at that point needs to, let's say, maybe brush up on some skills. And so maybe instead of some things that are very, very low level, like maybe just like copy editing, copywriting, so some jobs like that will go away. But from the software engineering part, you still need people that are critical problem solvers. You still need people that can evaluate and debug the systems. You need people who can like maintain all of this. Even I like to draw a lot of inspiration from the aviation domain. We have planes that can literally take off, fly themselves, and we've had that for a couple of decades now, like planes that can fly themselves. But you still need pilots. You need people that can implement like emergency or safety directives. So I think in general, jobs will change. The key point will be for all of us to adapt and to build new capabilities. I agree that there might be a bit of like effect on human learning, right? And so if you had something like ChatGPT solving homework over a generation, there might be some negative impact there. And there's a lot of work working in the education sector to ensure that like we can properly distill, how do we design the education system such that even if Gen AI is used, it doesn't end up becoming something that makes us all dumber at the end of the day. So, but all very, very good questions, Mistura. Thank you.
Yeah, thank you very much for answering that question. Any other question from the audience? Okay, another question says, can we get presentation also? How can we deploy a converged solution?
Yeah. So
how is it done and what's implication?
That's a great question. So AutoGen, like agent workflows can be written as like any Python. It's all Python. It can be written as a regular Python application or a Python function. It can be wrapped into a Python function, and then you can wrap it into an API and then just deploy it like you deploy any other system. With AutoGen Studio, what I showed was just like a no-code version of that. You can always export your agent workflows and then again wrap them into Python functions. I can send out the slide deck. There's nothing confidential there. I can send that out to the team after this call. Yeah. Or
okay,
there's
thank
also
you very
something
much.
around cost implication. So yes, it is expensive because each time the agents sort of go through a loop, they make a lot of calls to an LLM API. It can get expensive. Tools like AutoGen Studio try to show you like exactly how many calls and maybe at some point the exact cost for all of this. But we started to see a lot of users use open source models. So these days you can run some versions of open source models on your local computer, and that is one way to sort of keep costs down.
Okay. Or is it somebody's asking, is it free?
So there are a few providers that have like free models. So I think there's some provider called Grok that has free models, but OpenAI, you don't have to use OpenAI models. AutoGen works with almost all open source models. There's models that can run on your local machine. They're not as strong as capable as GPT models. That is true, but there are a lot of small models that like that you can run locally for free that also work with like AutoGen.
Okay, thank you. Is there another question from the audience?
And by the way, I can also
let me ask one. Okay.
Yeah, I think that would be the last question.
Okay. And let me ask this question before then. At the moment, I think for a single agent, actually, we have a lot of black box already. So with this multi-agent, so that will be a lot of black box, and how do we reconcile with this interaction between several models?
Yeah, so one of the things we're working around is tools for profiling. So essentially, as the agents work through tasks, can we create tools that, first of all, login tools, what exactly happened? So every time like an action is taken, some messages received, some messages generated, some code is executed. We'll keep track. We have infrastructure to keep track of all that. The second thing that we are working on is some sort of profiler module where we can label all of the tasks that the agents have worked on. So for example, we can say within a session, there were like, let's say 100 messages generated. 50 of them were related to error, like recovering from errors. Only about 10% of them actually led to actual net task progress. So essentially there's a whole research area that's, I believe, will continue to grow, just focused on, think of it as explainability for multi-agent systems. So retroactively profiling and just peeling open the box and inspecting what the agents are doing. So there's space to do all of that. All of this is very open and fairly new research, but we are thinking about that. Yeah.
Yeah, thank you very much. Thank you so much for the session. Really appreciate your talk and the question answering session as well. Thank you very much.
Thank you so much for having me. I'm happy to connect with everyone down the line. Thank you so much.
Thank you, Dr. Dibia, for the amazing presentation and talk. And thank you, Tunde, for facilitating the Q&A session. So at this point, before we move to the next speaker, I would invite all of us to take a 5-minute break. So just, stretch your legs, take some water, and then come back. So we will begin at 1:23 p.m. We will resume at 1:23 p.m. So don't go away. I mean, don't log out. Welcome back. So we'll be moving to the second speaker, Mr. Ridwan, who will be talking to us about intelligent chatbots in academia, a new era for literature search and scholarly writing. So Mr. Ridwan Salahudeen is a computer scientist with a strong academic background. He holds a BSc and MSc in computer science from Ahmad Bello University, Nigeria. With teaching experience at Ahmad Bello University, Zaria, and the American University of Nigeria, Yola, Ridwan's passion for cutting-edge technologies drives his pursuit of a PhD at Wuhan University of Technology, China. And currently, he serves as a research associate at St. Francis University, Hong Kong. Ridwan's research interests encompass deep learning, blockchain technology, knowledge presentation, and uncertainty resolution. Ridwan's dedication and contributions to funded research and software development projects in both Nigeria and Hong Kong highlight his ongoing impact in the field of computer science. Without much further ado, I would like to hand over to Mr. Ridwan for his presentation.
Good afternoon. Can you hear me?
Good afternoon. I can hear you loud and clear.
Oh, okay, thank you. I need to share my slide. Okay. Can you see my slide?
Yes, sir.
Yes, I can. Yes.
Okay, thank you. Thank you for the invitation. We just go straight into the presentation. Actually, my task today is to walk us through some hands-on skills on how to navigate these large language models. So to do that, I come up with some slide to at least give us some background to the technicality that are involved in this LLM. Then I hope we can then have an efficient navigation with the hands-on henceforth. So I will briefly talk about, like the last presenter, Dr. Dibia, has really made my tasks easier. At least we know better what these LLM are opt for. But I think I can still just snaply move through the slide. So yeah, I'm just again re-emphasizing what these LLM are actually. And as we have heard earlier, they are just general purpose language model that are already pre-trained on large corpus of data. As at the time when ChatGPT, which was the pioneer in this field, came out as at 2022, it was reported that it was trained on text data of about 45 terabytes of memory space, having around 175 training parameter. So these are huge models that are trained on huge data. Like I mentioned, the ChatGPT was trained on the whole of the internet text data as at that time. So basically what this model are aiming at is to learn the pattern in text, natural human language representation, such that the contextual meaning in text are known by this, are well understood by this model. And then henceforth, human can interact as if they are actually interacting with a human, like making some conversation that is human-like, but actually they are not human, as we all know. So there are some basic building blocks that I feel it will really help our hands-on demonstration, which again, I will walk through quickly. The building blocks are in 5 components. There is the tokenization, then we look at embedding, after which we talk about attention mechanism, and then how these 3 previous concepts are used to train this model, such that this model can then be used for downstream tasks using the fine-tuning concepts. So starting with the tokenization, really, like the last speaker told us, that in computing, the major objective in any computing task is to break down a complex task into a manageable, a minimal size. And that is the starting point, even with the language model, with the concept of tokenization, which is an area of research on its own. People have done a lot of tremendous research on that. At least I have like a survey paper here that I'm citing here, published 2021. So what tokenization is all about is to process a sequence of text into a smaller part known as token. Doing such, we actually can easily make a machine to analyze this text. So for instance, as shown on the right-hand side, we have a text, like a very long text. So for a machine to process this text, it will be fed into a component of tokenization now. And what that is, the output you are going to get from there is to have the long text chunk into the smallest unit of meaning. So it will have each word from the text separated out, such that each of the texts can have a meaning to itself going forward. So it has been tokenized into GRU, AIM as an adjective, representing some a concept, and so on and so forth. So with that, we can have the machine can be trained to have an understanding of the text, and even subsequently be able to generate a pattern within the text. So after the natural language text has been tokenized, the next step for an LLM is to have a representation for these texts, for the tokens now. We all most likely have heard that computing are just series of or bits of zeros and one. Really, when you open up a computer system, you will not find any of your text or any of your videos, any of your music. You cannot find it there physically. They are actually represented as bits of zeros and one. So therefore, there need to be a way of embedding the text that we have tokenized into a representation that is understandable by a machine. And that is what the word embedding aims to achieve. Again, this is another area of research on its own that has made tremendous effort. So I'm just giving as instance on the diagram here, This four concepts of man, woman, king, and queen can be trained to a machine to understand the contextual meaning of what really a man is, what a woman is, by having a vector representation. And once that is being done, they can now be manipulated in the vector space, and you can easily see how words are correlated to each other. For instance, a man to woman is similar to what a king is to a queen. And from a man, you just need to do some mathematical manipulation of addition, multiplication to convert a man concept to a king concept. And else, probably you can guess how these LLM generates words sometimes. So after that, there's another very pivotal concept in the lifetime span of LLM, known as the attention mechanism, which came out around 2017 by Google research team. And this is actually one of the changing points, because the paper itself is called Transformer, and it really changed the dynamics of natural language processing. And the aim here is to make these tokenized words that have been embedded to be able to attend to each other. Hence, you can just allow them to learn by themselves, by the term known as self-supervised learning, instead of the supervised learning that is more common with machine learning. You can now allow the text themselves. Any human need to label any text. So it's really, if you are probably interested, you can look up to this paper by yourself. But I mean, this is one of the major turning points of natural language processing. The tokenized embedded word now can attend to themselves and derive meaning by themselves, as far as you have tons of data given to this deep learning model. So, having mentioned that the learning itself really can be self-supervised without any human intervention, the next major step is to allow the training let's allow the training to be done by itself. And at around 2019, again, this same set of researchers from Google released this paper known as BAT. It is bidirectional encoder representation for transformer. All they needed to achieve there is to have a representation learning, like allowing a deep learning model to go ahead to make that learning. So the previous attention mechanism is just to show that this is possible, but this is when it was actually done. And this is what the likes of ChatGPT also, it's like an infrastructure that they build on. So as it is, it was trained on large amounts of data with billions of parameters, like I mentioned, and purely unsupervised learning. It was passed into the transformer model, and hence we, like the ChatGPT in particular, use some man in the loop model to at least correct the model in some of the hallucination problem that it was having as at that time. Well, we all know that even the hallucination problem still exists in most of these LLM, but like I want to believe that if you have been following the progress from 2020 to date, these hallucination problems are gradually, I don't think it can be solved totally. Of course, I don't think so, because we are still going to see in some of the slides to come. But then I'm saying here that the pre-training has enabled the fine-tuning to be done by this LLM in a more efficient way for downstream tasks. So in the fine-tuning, I try to make an analogy with the image classification and recognition that we are so familiar with. Most likely, at least on our phones, we know that we can use our biometric to have our facial recognition and so on and so forth. This is probably to some extent visual to many. So if I'm to build on that, I want to build on that to talk about how it is being done on natural language processing. So imagine this is a data set known as ImageNet. ImageNet is a huge number of images, I think around 14 million images of 1,000 classes that you have images of cat, dog, spoon, chair, house, and so on and so forth in 1,000 classes. So the actual ImageNet was pre-trained on a very deep neural network, such that the model has the perfect recognition of any image within these 4 million images. Any cat image, for instance, you pass through this, the already trained model, the model will easily, or to some good accuracy, recognize it as a cat. If it were to be a dog, it will recognize it to be a dog. If it were to be even your face, for instance, it will recognize it as human, and so on and so forth. So such kind of model are actually expensive, just like the last speaker also highlighted. Like training this model are not, they are expensive budgets by big companies. So what is mostly done in the research, in the academia or in the university, is to get a pre-trained model of such capacity and fine-tune it to your own downstream tasks. And in this case, I'm using an instance of medical data set. Suppose you have a project of recognizing malignance and myelin in a cancer. Just you want to solve some cancer problem, cancer recognition. So you can easily use a pre-trained ImageNet model on a very small amount of data set that you are having now, maybe in hundreds or less than 1,000. You perfectly, such model can easily be fine-tuned for it to now recognize a myelin from a malignant cancer. So with this understanding, it is very similar to what is being done on LLM, on natural language processing. I mean, in natural language processing now, it is actually not visual now. They are text, and how to really say a text A is similar to the text D, that's THE. For instance, to make the correlation is not as easy as image. Image are based on pixel, whereas text, there is no even any uniform length of text representation. A text can be just a character. Some text can be as much as 20 character. I hope you get the point I'm making. So in order to do that, there is what is known as reinforcement learning from human feedback. That is the techniques that is being used to train, to fine-tune most of these models. And what is being done is the pre-trained bots will be given to some human evaluators, and then they will write some prompts to maybe in the form of question and answering to interact with this model. And based on the responses they are getting from this model, they can now give some score to the responses. And from reinforcement learning is actually about feedback, where you need to give reward or punishment to your agents from whatever response you are getting from it. If it's performed well, you give it a reward. If it's not performing so well, you give it you give some punishment. So that is with this feedback, this model are better fine-tuned, and like I was saying earlier, even the hallucination problem is not as much as when the original ChatGPT was released, and so on and so forth. And again, this is the actual ChatGPT paper released in 2022, in case you are interested. So to sum these technical terms that I've just used to give a sum on it, and then we can move on to the hands-on. I want to give this analogy that the tokenization that I started with is like organizing books in a library. So suppose you have a library, you need to organize the books in the shelf. So you need to like relate with the books individually first. You cannot just use the cart or the container that the book were delivered with, and you cannot work with like that. You need to like bring out the books individually and try to probably label them, and to do any further action, you need to handle the books individually. So after that is done, you now, the word embedding is like arranging related books on the shelf now. So after you must have label, you know the best shelf to move each books to. Then attention is like having, like in a library, there are a lot of personnel that are assigned different tasks in the library. I mean, people have different specialty. Some might be charged with the responsibility of studying, knowing the trend in social sciences. Some might be given the responsibility to just focus on computing, and so on and so forth. That is the attention. Then the pre-training is like learning all the context in all the books, like the whole library itself. It's a gamut of knowledge, right? So when you bring all of these groups together, probably when they discuss, you can, it might be fascinating to know everything that is going on in the world, likely. Then fine-tuning is now like applying that general knowledge from a library to a specific task. So together, this building block can empower or do empower LLM to excel in understanding and generating human-like text. So now moving to the hands-on, I am hoping we have enough time to do some practical hands-on, but just as a backup, I've already snapshot some of the demonstration I had on slide, but I think we can still do some physical hands-on on the web browser. So again, yeah, I will be honest, I feel many of us have tried one or two of these chatbots, and probably some of you are even better than me in knowing the latest. But really, I just pick out some of the few I know. And I started with the Microsoft Copilot. Reason being that, again, OpenAI, that's ChatGPT, was known to be the pioneer in this field. Like I already gave some background, even though they are not, they also ride on the effort of the transformer, and so on and so forth. But really, at around that 2022, they were the pioneer, and we all also knew that ChatGPT, which is owned by OpenAI, are funded by Microsoft. So most of Microsoft's products now have they are very, very good in this, like they have a good plugin to ChatGPT already. So talking about the the search engine of Microsoft known as Bing, the browser Edge, its Office suite, the virtual communication platform known as Team, or the operating system itself. And then I will be talking about some of the engineering tricks that we can use as researcher to, I feel that is probably where we need this LLM most. How can we interact with them to help some of our research work? So I want to also talk about some of those prompting engineering concepts. The major one I will focus more on is what is known as retrieval augmented generation, or RAG. Here you have the LLM itself. Like we have said, they are known to be fabricating facts sometimes. That's the hallucination. So in order to make the outputs more trustworthy, or more like something that you can really depend on, you can fine-tune it by giving it your own knowledge, like probably some work that you know about, or some paper. So in this case, it should be like the database now that the LLM can interact with. So when you ask a question in the form of query, that will be passed to a retriever. The retriever, if it doesn't have any related facts about that query from your database, definitely it will just give you whatever it knows from the data it has seen before. But to make it better, you can give it your own background knowledge, and then it can be fine-tuned on that to give a better output. So I'm going to demo with this small PDF. Small PDF is one of Google products also. Most of these applications now have tons of. I stumbled on this small PDF because I think last 2 weeks I was searching on Google Scholar, and I quickly saw that you can. I think I should just go internet now. So on Google Scholar, are you still seeing my screen?
Yes, we can.
Okay. So if I move to Scholar, for instance, because as researcher, we use Google Scholar a lot, I want to believe. So on Google Scholar, searching any concept, let me say talking face generation, okay. So you can see once you type in anything that you search on Google Scholar, if that's what the output of your search, we come up with some that have PDF linkage and things like that. So some of which you will see this summarized with AI on it. So it means it has the small PDF enabled on it already. So if I click on that, to take me to the paper, not just taking me to the paper alone, but I can interact with the paper, like hands-on now because it is opening on that small PDF application. That might take some time because of the internet and streaming of the video. This is taking too much time. But I feel we get the gist about what I'm trying to say. It's just one of the many platforms that you can use to interact with LLM. Probably it has still not come up. Okay, like I said, I already have some screenshots. So I interacted with the small PDF on this particular paper. It's actually an MSc thesis I saw online. So by default, it will give you a summary of the paper by default. So it's already told me the background of that paper, the methodology that was used, and the key points, that's the findings of the paper. And then you can now go ahead to make your own further interaction. And I asked what are the major findings. It gave me these 3 bulleted points. I asked further some questions, which I also asked it to give some relevant references, and that's why it's bringing up this. So actually, I find that to be interesting, but it's not that elaborate. Again, this is one of the 3 I've found that work well with LLMs. You cannot just depend on one. At least you need to have some options that you can work with. So another that I've seen that is working well is this Adobe Acrobat, which is the normal PDF that we are used to. So they have already included a plugin known as AI Assistant. And I asked that same question to the same paper that I just showed you now, the same thesis material that I just showed you now. But when I asked it about what are the major findings, you can see it is a bit more elaborate, and it's even giving me some link to the text. So if you click on this, it will take you to the portion of the text where it got that information, and so on and so forth. But the drawback about this is it's not free. You can see it's already, I tried it with my Google account, and I think I was not monitoring that I have some number of responses that I need to that I can explore with as free version. So until after a while, it told me I've exhausted that, so I use another account to do that. So already now it's telling me I only have 3 requests left. But really, for me, I feel I don't need to pay for any of these LLMs. So I'm not going, but that is another option that we can use. I'm trying to highlight here. The other is the Copilot that I talked about from Microsoft. It is also very, very efficient so far with the interaction I've had with it. Again, once you open any PDF document on, say, Microsoft Edge, that's the Microsoft browser. Once you open any PDF document or any Word document, it will give you an option of Ask Copilot, for instance. So on clicking on that, you can then start interacting with that document. For instance, this is a document I stumbled on just yesterday, which is talking about some 10 rules for you, that you should abide to as a researcher when working with this. I already have it in my slide that we talk about. So you can interact with co-pilots on that document, again, the hallucination is still there, trust me. For instance, I asked this last question, the 10 rules of using LLM. Okay, before that, I asked it, enumerate the 10 rules. It then responded as, I'm sorry for the confusion, but I don't have the specific details of the 10 rules, blah, blah, blah. So I went ahead to at least fine-tune my question that the 10 rules of using LLM in science mentioned in this article. So it's brought up this, but trust me, that those are not what the paper really mentioned. It does frame up some things. So moving on again on my slide, you can also discuss mathematical notation, because most of us are in sciences, and I think one of the major challenge is, how can I tell an LLM, how can I discuss a mathematical notation with an LLM, for instance, like I'm having in this snapshot, I said, hey, can you explain this mathematical notation for instance, and it went ahead. It understood. You can see how I wrote this mathematical notation in a way that the LLM, in this instance, ChatGPT, understood, and it break it down in components. The problem here is that there is no way you can write a mathematical notation directly, like a formatted mathematical notation. There's no way you can do that with the prompts area that you normally used to have on any chatbot. So what I mostly do is to pre-format my mathematical notation on another useful application known as LaTeX. As researchers, I want to believe most of us work with LaTeX, so you can like out your equation on LaTeX and just copy that portion. I have it as a screenshot somewhere. Yeah. Okay, yeah, I'm also asking it to, like you can see, yeah, this is a very interesting interaction I had with ChatGPT. Like I was on a previous conversation with it, and I want to like come up with a mathematical model with an idea I'm trying to come up with, something like that. So I now gave it, I said, explain the denoising network based on the diffusion formulation, this and that, where that. Okay. But I think it's not the one I'm looking for. But what I'm trying to say is, you can like teach it a concept and let it map that concept to the idea you are bringing up as a researcher. It can probably help you with a mathematical formulation to your idea. Of course, you should be wary of the hallucination, but at least it can be a starting point for whatever you are looking for. So that is that. So talking about how to get the good representation about the mathematical notation, I mentioned earlier that what I use is LaTeX. So this is a snapshot of some of the equations I've been like working with so far and interacting with ChatGPT. You can just have a single document where you have them continuously that way. So it's another week on its own, but you can have, okay, this platform is known as Overleaf. Overleaf is an online engine for LaTeX. So anybody can go, as far as you have a browser, you can open up overleaf.com, and you can have as soon as you write anything, you can compile it, and then it will give you at least to give you the visual representation of what you are looking for, to validate that this is what you are looking for before you can now copy that portion. For instance, I will copy this portion now to a ChatGPT and ask it, okay, let me do that, and so on, for instance. So this is one of the ChatGPT that I've been using. If I paste this, oh, sorry. If I paste, oh, what's happening? Maybe I didn't copy it well. I can copy again. Copy, yes. Come here, paste. Yes, it's still not looking nice, right? Because I'm still on the prompt area. But as soon as I click on it, it will come out nice. You can see. You can see. I've not even asked it any question, but it's already explaining the equation to me, blah, 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 for instance. So that's
Please, Mr. Ridwan, you have 10 minutes. You have 6 minutes more.
Sorry. Oh, okay. So let me wrap it up by saying, yes, this is probably not too necessary, just to show you that it's a rush between these big tech companies, and that is still going on. But there is a rule of thumb that I feel I should share as a researcher. Like I mentioned, that paper that talked about 10 simple rules for using large language models. They have it in two collections: the safeguards and what are the things that are like healthy for you to use LLM for. So the safeguards are, first, you need to follow the rules of the target journal that you want to submit to. Now, some journals have like explicitly mentioned that AI-generated content must be spelled out or something like that. You need to tell them that social portion of your content is generated by AI, something like that. Then online relevance. Okay, outline relevant tweaks before LLM use. That is, you should know better your research. There could be some content of your research that might be risky to, again, this LLM, remember that you are giving them some, you are providing your information are also being used to train it further. So whatever you are giving to it, there is a risk of like the privacy of your information might be at risk. So that's probably what this is mentioning, what this is talking about. Then also avoid plagiarism, respect confidentiality, verify the truthfulness of content. This is very, very important. The truthfulness of the content generated by LLM before like submitting to any journal or something like that. I will encourage you to look at this paper. It's very, very interesting. Then these are these 5 things that, yes, you can use LLM for. Maybe the data search. That's you just want to have a great idea on a research area that is not your field. You can just make it as a starting point. For instance, you can use it to summarize content, can use it to refine your English, like some of us that struggle with, for instance, I have that problem myself. So I think that is very, very useful for me so far. Then use an AI to improve your scientific coding. Again, yeah, you should be careful of hallucination. I've seen it many times. The code, yes, they can generate code, but many times those code might not be really, really that good, or might even be traveling, like taking you to another world. Then lastly, you can also use it to jumpstart your scientific writing. Yes. Finally, I want to, yes, I use this as, I use this prompt to generate this image, and at least to tell us that for any researcher, we are in constant search of novelty. But again, like the last speaker talked about, in reaction to Dr. Mistura's question, like there have been transformation over time from the internet and so on and so forth. But we will not stop using this facility. But then we should know that the researcher must always use their mind to identify novelty. The LLM cannot do that for us. So thank you for listening. I think I can stop here. Thank you.
Thank you so much, Mr. Ridwan, for that wonderful presentation. So at this point, I'll hand it over to Mr. Tunde for the Q&A.
Yeah, thank you so much, Mr. Ridwan, for the talk. It's quite interesting. Thank you. So, do you have any question from the audience? Any question from the audience? Oh, let me start with this. The PDF on Google Scholar that you talked about, do you use an extension or something?
The PDF
or
on
is it
what?
free
Sorry?
available on the Google Scholar?
Oh, no. It's publicly available. It's publicly available. You can search your Google Scholar right now.
I just right now, it's not here. Maybe it's country specific or something.
Oh,
probably.
Okay.
If you don't use any extension,
Since you're still sharing your slide, maybe you can just go to your browser and then probably show it a short demo.
Okay. This is the screenshot, right?
Thank you.
This is Google Scholar, like it is virtual. It is not local to my system. You can see, right? So as far as you are on Google Scholar, you search on anything, for instance, as far as that thing has a PDF version, it should come
I think
up
you
with...
have an extension. In yours, you can extension.
Yes.
Yeah, you do.
Also, you need to have a plugin, to your browser.
That's
You need to add that to your browser plugin. But the name is just Small Talk. I think you can just search Small Talk. Small PDF, sorry. Small PDF. Yeah.
Okay, that's my
Maybe
question.
if you follow this site, it will tell you how to put the plugin on your browser and so on. I think that's where the problem might be.
Okay, I think that's it. I'm trying to ask that. Then another question is that I tried a couple of all these LLM agents or all this website also. I feel like each of them have they are centric on one particular goal or something. Is that correct? For instance, I think maybe the Gemini from Google, I think. Then the one from the Copilot from Microsoft. I think each of them have a particular focus on things that they do. Because if you ask them the same question, they tend to give different answer or something sometimes, or the way they construct the response differs. Is it just my observation, or that's just the way they are? Because I feel like the Google are mainly for research and all, and the Copilot are mainly for maybe writings and all this stuff. So, is that correct?
Yes, you may be right, Mr. Tunde. Like I said, my advice is you need to, because there are a lot of them now. Even I stumbled on another blog talking about the intention of Meta, that's Facebook. And from the slide I showed, you can see Facebook is one of the ones that have bought all the GPUs before the release even. So the point I'm making here is I think it is true that each of these companies have their focus, they have their major objectives. So for instance, the Microsoft might be more intuitive to things that had to do with the open AI and so on and so forth. While the Gemini of Google might be more because they have a lot of data from Google Scholar. That's the Google now. Google has Google Scholar, right? And Gemini is from Google, so probably they might. But honestly, I cannot give a very straightforward answer on that. I just try as much as possible myself to compare and contrast. Yes.
Okay, thank you very much. We have a question in the chat box. It says, how are they able to come up with variation on ChatGPT that can do different things like GPT 3.5 and GPT 4, like in terms of image generation? Because it says only the paid GPT 4 can do that. This is not available on 3.5.
Yes, how were they able to come up with different? Yeah, like I said, ChatGPT build on the pre-training of transformer, right? So, and this transformer was originally trained on text, natural language processing. So it was later on that some researchers went ahead to also incorporate such concepts to vision recognition, because these are two contrasting idea in deep learning, and there are people of computer vision and there are people of natural language processing. So ChatGPT started with what was available, that's transformer. But as the technology gets more improved, we have what is known as diffusion model now. Diffusion model are very good in image generation. So that's where some of these image generation are now coming in with probably the upcoming versions now. I don't know if that's answered that question.
Okay, thank you. Maybe if your answer is if your question is answered, you can signify. If not, you can actually maybe reframe your question. Somebody is raising hand. Mr. Ridwan, can go ahead.
Yeah, thank you so much, Mr. Ridwan, for the wonderful and insightful lecture. Thanks so much. So my question revolves around the hallucination of the large language models. So in a case where you have, let's assume you have a database and you try to use the RAG and also have the prompt layer, is it possible for us to mitigate or to avoid the hallucination by using this method?
Yes, very likely, very, very likely. That's if you can confine your training to your data set as much as possible. And that is the trick now with the RLHF, reinforcement learning with human feedback. There are some tricks also that are being used there. Like you need to balance between what the model needs to search online and what the model needs to rely on your own knowledge base. It's a balance that you need to work on there. So if you can really optimize that balance, then yes, that can be achieved.
Okay, thank you. There's a question in the chat box that says, each time I use the premium GPT and the non-premium GPT for econometric calculations, the solutions aren't the same. Which one can I rely on? Okay.
Yes, buy the premium. But honestly, I feel I will never buy any premium because I feel like it will even make me more relying on this ChatGPT. Well, I'm not of course, you should expect that the premium should be better in terms of the generation. Generation now, they can be telling you all sorts of things. That it might not be factual. Like we saw when I compare the small PDF with what the Adobe was giving, the Adobe was more elaborate, but the small PDF at least gave just some short points. The factual, like the correctness of the point should be what really matter, not ChatGPT are just good at giving. You can ask a ChatGPT to give you 1,000 words for just say good morning, for instance. It can do that. That's how interesting they could be. Yes.
So another question is the question that says that I always encounter issue with authorization key required for downloading Llama 2 from the Hugging Face repository. So which other options are available?
Yeah, Hugging Face are one of the best bets when you want to get this pre-trained model. If you cannot get it free on Hugging Face, I don't know where else, honestly. For me,
I think
Hugging Face.
Somebody responded Llama CPP wrapper function also.
Okay, you can try that. I'm not sure.
Okay, any other question? Thank you, Dr. Toby. Any other question? Okay. Is a question that they ask how they can contact you. Would like to work on project that revolves around text mining.
Okay, I'm always available. You can reach me through the executive. Definitely,
Okay. Thank you so much for the presentation. If there is no other question, I think we'll come. This is the end of the question and answer section. Thank you so much.
Thank you. Thank you. And thank you, Tunde, for the talk and for organizing for facilitating the question and answer session. I think what I would suggest is maybe you can just run maybe calculations that you are sure of, the ones you know the answers, and then compare and then see which one tilts towards what you already know. I think that way you can improve on the one you can trust. So that brings us to the end of the talks. And today, moving forward, you're going to talk about the AOB and the closing remarks. And on that note, I would like to invite Ms. Ifnaya.
Okay. Thank you so much, Mr. Ridwan. That was a very insightful presentation. And I believe we've learned at least something from that presentation. For the AOB, first, let me announce that, let me mention that we've only received 16 payments for the annual due this semester, this session. And please, we are over 100 members, so we encourage us all to pay up, because this dues enable us to run a lot of the activities that require some financial commitment. So please try to pay up. If you are yet to pay up, the account details are displayed on the screen, or you can contact the treasurer, Mr. Abdulgafar, directly to pay. Thank you so much. And also for the souvenir, we are yet to begin dispatch of the souvenir, but we promised that from now till June, we should have this on ground. But we just wanted to have an idea of what we are planning to give you for this session. So we'll be giving the t-shirt, the ANSHK t-shirt, and also the head warmer, customized head warmer, also the table clock and the leather notebooks. So we have these 4 items for the souvenir. So please pay up your dues so that you'll be eligible to receive your souvenir. And before I move on to the next item, please, if you have any issue you want to raise, if you need clarification, if you want to air any opinion, please, the floor is open, brother, for you to do that. And if you have any suggestion for the ESCOs, or if there are things you want us to implement into our programs, your suggestions are welcome, and please do that at this time. Thank you. Okay, in the absence of any suggestion or comment, these are our social media handles and our email address. Please, if you're yet to follow us on social media, kindly do so on Instagram, Facebook, YouTube. You can watch our numerous videos on YouTube. Then you have the website. Though the website is not very functional at the moment, but we are working on getting it in place as soon as possible. Then this is the email address, So if you have questions or queries, please feel free to send us your questions via this address. And I'll be taking the concluding remarks. And I want to appreciate everyone who has been part of the event. We spent almost 3 hours already. And we thank you all for staying put till the end of the program. Especially, we want to appreciate the speakers on behalf of ESCOs and the members. We want to thank you so much for making our time to be with us here and to present your very insightful topics. We are so grateful. Thank you, the guest speaker, Dr. Dibia, and the facilitator, Mr. Ridwan. We've learned a lot from you. I believe the sessions were a bit technical. Maybe for those of us in social sciences or humanities, it might not be so easy, but I'll enjoin everyone to try to get ourselves acquainted with what was discussed today, because actually the world is moving towards AI and we cannot afford to be left out. So I believe the things we've learned here today, we can integrate into our research, and it will go a long way in helping us to make good progress. So I want to remind us of our upcoming events. Next month, we have okay, so next month, that's May, we'll be having a sports event, and it's an indoor event. So yes, it's a very good time for us to stress so that it's not just academics and research. So please, we encourage you to come out en masse for this event. Then in June, we have the research forum. So very soon we'll be sending out the call for abstracts. So we enjoin everybody to participate and to be involved as well. We have another social event in July. By August, we have our election. In October, we have the Independence Day celebration and the handing over. So please do encourage everybody to support us for the rest of this event that are upcoming. Then we also like to encourage everybody to be open. Try to open up. If you have challenges, you don't just keep it to yourself, because it's said that a problem shared is half solved. So let's try to open up when we have challenges. And the SQs are there to assist, and the members are also there to help us. So aside our research, let's try to integrate, let's try to make friends and enjoy the company of other ANSHK members and other Nigerians that are here. It will help us a lot not to feel isolated. Then as we study, as I've mentioned, as we progress in our studies, let's also make time to distress. So that's why we're organizing the social events by next month and by July. And we do hope that you'll be in attendance. Let's be our brother's keeper. Let's not be selfish. Let's also always try to reach out to one another. That will help a lot in keeping us happy, yes, and making us feel, giving us a sense of belonging in the association. We are open to your suggestions and constructive criticisms, as that will help us to move the association forward. We wish to, okay, before then, okay, I just want to mention that as the speakers have stressed that they've emphasized it a lot, that AI should not replace our own abilities, because it's been a lot of problem in the academia right now, where people are getting lazier by the day because of this AI too. So the essence of this webinar is not to encourage us to relegate our duties as researchers to AI, but it's just for us to know how to integrate these useful techniques into our research. So it should be a synergistic relationship, and not us getting lazier. Yeah. So please let's always remember that. It's very, very important. So once again, I'd like to appreciate your cooperation and support for the current administration. We really appreciate you, and we look forward to enjoying more of them in the future. Thank you so much. And we'll be taking a picture session. Mr. Saporichi, please help us with the photograph. Thank you. So please, everybody.
Can we stop? Yeah.
Please put on
so
your.
if you can, just put on your video, if you can. So we take the photo in 3 seconds.
In 3 seconds.
Okay.
Okay, thank you. That brings us to the end of this meeting. Thank you so much and have a very wonderful day ahead.
Thank you all. See you in a minute.
Bye.